All right, so let's take a look then at a parallel circuit. Parallel circuits are going to have multiple loops within them, multiple ways of moving from the battery back to the battery. So the current can either go through the 40 ohms or the 60 ohms, so some of it goes each way. And so key things to understand is that the current is not the same everywhere in this circuit, in this parallel circuit. Instead, what's true is that the current will add up as you look at each of the branches. So the current through the 40 ohm and the 60 ohm resistors together equals the current through the battery. But the voltages are going to be the same across every part of the circuit. Everything is connected on one end and the other end together. And so that's how we're going to approach this. So let's remind ourselves of how to find the equivalent resistance, but then we're going to find out that it's not absolutely necessary to do that with this question, first of all. So if I'm asked to find the equivalent resistance, I can't just right away sort of write a formula out. With an equivalent resistance for the parallel circuit, it's 1 over equivalent equals 1 over R1 plus 1 over R2, and on for as many resistors as you have. So in this case, we would take 1 over 40, and we would add 1 over 60, and then once we find that answer, we flip it over, and we take the reciprocal to find the equivalent. Well, a lot of people spend a lot of time trying to figure out a common denominator, and I appreciate your remembering your math, but it's a lot easier to just plug this into your calculator. Like, for instance, calculators usually have a key that either looks like this, 1 over x, or they have a key that says x to the negative 1. That's more common. And so when I type this in my calculator, it looks like this. I go 40, type that in, and then I hit this key, and then I see this negative 1 pop up next to it. And then I do plus 60, and I'm going to hit that key, and this negative 1 pops up. And when I hit equals, I'm going to get this tiny little decimal number, and that's not my answer. I need to take the reciprocal, and in this case, then, that comes out to be 24. Okay, and so that's how you would find the equivalent resistance. But what's nice about these circuits is you don't actually have to do all that in most cases. So if I wanted to find the voltage and the current, the first thing I want to do is just recognize that everything has the same voltage. And so the voltage across the 40 is that same 6 volts that the battery is providing. And the voltage across the 60 is, again, the same voltage that the battery is providing. So it's 6 volts everywhere. And that makes it really easy then to find the current, because current, I just need to know the voltage across something and that resistance. I need just to sort of match it up. So the voltage across the 40 divided by the resistance of that 40, of course, is just 40. So we would take 6 and divide it by 40, and that's going to find us our current, okay, and that comes out to be 0.15 amps. And then if I would go ahead and do the other one, so find the current through the 60 ohm resistor, I'd want to make sure I use the voltage across the 60, but again, it's kind of nice because that's the same everywhere, so it's again going to be 6 divided by 60, and we get, in this case, 0.1 amps. Now, is there a way to sort of check to see if this is right, like we can do with series circuits? Well, absolutely, because if I do take this 24 and I take my my current through, or I find the current through the battery, so if I use that, I'm kind of running out of room here, sorry. So if I take that and I say the current through the battery should be the voltage of the battery divided by my equivalent resistance. So that's going to be my 6 that I keep using over and over again because it's the same everywhere. 6 divided by 24, I get 0.25 amps. Well, you know, that's what I get when I add these two numbers together. The current that's flowing from the battery, when it gets to this point called a junction point, it splits up, and turns out that 0.15 goes this way and 0.1 goes this way. So again, a good check for our circuits.